Welcome, everyone. Thank you for joining us this afternoon. I'm Joe Healey. I'm the Dean of the Thayer School of Engineering, and it's my pleasure to introduce our speaker this year, the 2014 Thayer Distinguished Speaker in our Visionaries in Technology lecture series. This is an annual lecture we initiated 2 years ago to recognize engineers and scientists whose work and insight have benefited society through revolutionary engineering solutions, through scientific advance, development of novel fields of inquiry, or being the leaders in policy-shaping debate. This year, our distinguished speaker is Dr. Jennifer Healey, research scientist in the Systems and Software Research Lab at Intel Corporation. Dr. Healey's been a research scientist at Intel in Santa Clara, California for the past 9 years. Prior to Intel, she worked in a few different positions at IBM and also for HP after receiving 3 degrees, a BS, MS, and PhD from MIT in electrical engineering and computer science, and also doing work at the MIT Media Lab. I had a chance to speak with her earlier today about her background, and it's interesting sometimes the twists and turns that lead us down a particular research path, and this is a message for our graduate students in particular. Her research was taking her in a particular direction as a graduate school when a back injury that she sustained rowing crew led her to collaborate with a friend, change direction, and develop an interest in wearable computing and conduct her PhD through the Media Lab at MIT rather than directly through the Department of Electrical and Computer Engineering. And this work, and very directly her PhD work at the Media Lab, led her to develop an interest and significant level of experience in what I will call broadly emotional sensing that's led to some of the work that she's been doing at Intel over the past 9 years. She's an expert in embedded sensor technologies and intelligent sensor fusion. She's done extensive research on situation and context-aware systems. She's currently leading several interesting efforts at Intel that I think we'll hear about during the course of our discussion today. And so I ask you to please join me in giving Dr. Jennifer Healey a warm welcome to the Thayer School in the Dartmouth.
Great, thank you very much. Hi, everyone. It's an absolute pleasure to be here. It's been fabulous meeting all of the faculty and graduate students who I've met so far. Just really impressed with the way education is done here. I'm very impressed with the entrepreneurial spirit. It's very different from when I was an undergraduate, and I strongly encourage this mode of thinking to just go with your inventions and sort of just take them wherever they lead. I mean, I think that looking back, I should have probably gone with a potentially a company after my PhD, but I've actually had an absolutely fabulous career, and one of the benefits of working in industry is that you can work with a huge number of equally fabulous people, and you have tremendous resources to build things. Today I'm going to be talking about machine-to-machine transportation systems. This is a portfolio of research that I'm going to be describing, and I work with a multidisciplinary group. I work with cognitive scientists, ethnographers, designers, and technologists, and we all work together as a team. We are a for-profit corporation, so we're actually very concerned with the real-world relevance of our work. We want to invent solutions that the world actually wants. So we do a lot of assessment of what the ecosystem actually is, what people are actually trying to do in their lives, and to try and create the solutions that we believe will help them and that they'll love and that therefore they'll purchase. So it's not entirely, altruistic, but we actually really do, we don't believe people are going to buy useless things, so we actually try to make our work really relevant. Now, one thing I noticed, I work in the car industry, and this is a Porsche Panamera, and I love this car. I've passed this car several times on Highway 101 because this is the dream car companies try to sell you. I work with a lot of OEMs, and unfortunately this is the vision that they have in their head. Professional driver, closed course, Farfignugan. It's just you and the twisty, turny road. And that all that matters is the power of your car. and its agility, its turning speed, etc. And this is driving, the ultimate driving experience. Now, that is great. In fact, my husband and I actually went down to Carmel by the Sea, and we actually got to go on a road like this. It's the one time I've ever been on a road like this, and at that time, we actually saw a lot of fancy cars doing that, because this is the one time you can enjoy this car, because unfortunately, this is what life is really like. And I've driven my fancy BMW up and down Highway 101 at about 5 miles an hour. Before that, I had a manual Jetta. My husband's like, yeah, the manual, it gives you total control over the car. I'm like, great, one, neutral, one. This is great. I feel so much power over my drive. And so I'm so in control. I'm like, okay, great. We came up with this hypothesis that the future of driving doesn't have so much to do with the drivetrain and engine and the speed of the car as to how much of this time that you're going to spend in traffic you can actually recapture, and how much more efficient you can make your drive. Now, I'm going to go through the whole cycle of our research. I'm going to talk about the ethnographic work that we do, the design work, and the technology work. So I'm going to take you a little bit through the portfolio of projects that we have. One that I was directly involved with was called Local Experiences of Automobility. Intel is a global company. We have to understand how people drive globally, and it is different. So we went around the world. Our focus was mainly in Germany, Brazil, and China. And we actually went into people's homes, into their cars, into their daily lives. We did a fusion of technology and ethnography. I don't know how many of you are familiar with ethnography. I didn't happen to know about it when I was in electrical engineering school. One of my friends' wives was that. I'm like, what is it? It means the study of people. And one thing ethnographers do is they used to go in and embed themselves with groups of people to understand what they valued, how they lived, what was their daily practice of life. We can't afford that, so what we did is we went in and had 2-hour interviews with them, put a GPS in their car, and put an app monitor on their phone, and then we sort of embedded our technology in their lives. And we sort of learned from that. We tried to use those as a proxy for an actual human. And we actually did this in these 3 countries substantially, and we left these monitors in there for a month, and we were trying to study what is the daily practice and experience of driving. We started from very foundation. We're trying to revolutionize transportation. We wanted to start from the very foundations of understanding what transportation meant to people in their daily lives. So, a little bit about this. One of the practices is to empty people's cars. We had them take everything out of the back of their cars. We had a shower curtain. We had them put everything onto the shower curtain. Right now, you'll see this is Singapore. Surprisingly, they have a huge amount of umbrellas. In Brazil, they have absolutely nothing in their car, maybe a bag of trash. Why? They get robbed all the time. It's not funny how often this happens. And you know, if you try to sell any kind of in-vehicle infotainment system, which is our main product, into Brazil, they will laugh at you because there is no way they're putting even a stereo in their car because they get robbed that frequently. And how much people in Australia carry chainsaws, carry things that you wouldn't believe. And just going sort of worldwide, just to see what the daily practice of life. In China, people had all these sort of like different tickets and various branded tissues in their car. And we're like, well, that's what you need for daily life in China. You need to have these things. And we went to Singapore, and they had these emergency red envelopes, just in case the gift they hadn't brought to some wedding wasn't quite good enough. They could always add a little cash to sort of make... They called it an emergency envelope. I'm like, what is it like? Do you rip it when there's an emergency? And like, no, it's a social emergency. I'm like, which talked a little bit to us not only about this idea of storage. The cars also had this sort of physicality and storage component, and also these artifacts let us know things about who drove the car. In China, it turns out that one car gets driven by a multiplicity of people. Because they can only afford one car, so how the car is shared between people and why. One of the things we do in an ethnographic interview, and as a nerd, I had to really restrain myself during this. They'd ask the people, so what does this button do? And I'm like, oh, I know. It's ABS. And they're like, no, you don't answer the question. It's a trick. So the psychologists in the room will know this. You just want to see what the people know about their car. And one of the things that this is important about is if people don't know what the button does, then it's not of value to them. So if you want to figure out what people actually use in their car, you ask them what the buttons do. If they don't know, they've never used it. We had one lady who called the Bluetooth thing. She's like, "Oh, that's the lady button." I'm like, "What?" Like, yeah, it's some lady's voice comes on. I was scared, and I'm like, "I never touch it now." Because apparently it was OnStar and it was going to try to help her, and she's like, she didn't understand. There was just this disembodied woman's voice in the car. She's like, "Don't touch it." Okay. But people don't read manuals. People don't understand half the functionality. Trying to understand what functionality they do and don't use, do and don't value is part of the value assessment. When we're trying to develop a new system, one of the first things we do is sort of needs assessment, appreciation assessment for what are the various features. One guy, he liked the tire pressure sensor thing. He could flip it on, and he's like, "Watch this," and he did a turn. He's like, "Look, they're all the same." It's like, awesome, right? I'm like, yeah, okay. I didn't realize it was used for that. Different things we did. We had people do camera diaries. They took, this is my work. This is what I love about my car. My dream car is, and they took what is significant to them. We had, this is a, I don't know if you can see it here, sound pressure sensor, light sensor to see what are the range of temperatures and sounds that the car experiences. What's the background noise? What's the background noise like worldwide? And part of this was for a monitoring system. We wanted to have cars in a soft on position to do 24/7 monitoring. We wanted to see what the sort of variance was over the time. We installed an app on the phone, and what we did is we time synchronized the app with the GPS unit so that later we could find out what was happening at each point in time. So we took the two together. We did, in KLM and Google Maps, we did an overlay of the two things. And so if you were playing the fish game while you were, we had to make some assumptions. We had to make an assumption that the person who had the phone was driving. So we tried to make that's like one big unvetted assumption. And then we assumed this was happening in the car with the driver with the phone. Not always true, but it was a good approximation. But because, trust but then verify, we had these follow-up interviews where we asked people questions about their data. And one of the things we learned is that sometimes the car went places and the owner had no idea where it was going. So we would study the maps. We could usually figure out what was home, what was work. It's amazing what you can figure out from a GPS, in case anyone here is studying privacy. And the GPS is on your phone, by the way, which is if you use any service tied to your name. Anyway, so if you want to know what people know about you from turning your location services on, which I'm going to guess about 80% if you currently have on, there's a lot people can know about you, and I'll just show you some things later if they care to. I like to scare people, part of my job. So we'd have these follow-up visits, and it was interesting that sometimes the car would go places the person wouldn't know. And this has led us to talk about not only decentralized, but person-specific data collection, because maybe you don't want people to know what your GPS, if you took the car, where you drove, because it's being recorded. But who has access to it? Maybe you want them to have it, maybe you don't. Anyways, so what does this embedded technology tell us? This is Germany, and we had this guy say, "Yeah, I was looking for parking for over an hour," and we're like, "Oh yes, well, even Germans exaggerate." Turns out no. This guy was literally looking for parking for over an hour. I have the timestamps to prove it, and the GPS. His friends had to come bring him a Coke. It was like this nightclub in a popular area, and he just was driving around. And and since then, I've heard these ridiculous estimates of how much of urban traffic is people looking for parking. I've heard up to 40%. Which sounds like absolutely insane to me, but it helped us highlight that in urban areas, parking is more of an issue. That in terms, if you want to talk about transportation systems and optimizing a transportation system overall from start to end, not necessarily getting you there. I mean, it doesn't matter how fast your engine is when you can't find the parking space. This is a tremendous waste of gas, pollution, urban resources. So this is part of how ethnography helped us say, well, what's really a problem in transportation system? And this isn't the only incident. What are people trying to do with their IVI system. This is a guy who told us that he only ever uses his cell phone in case of emergencies. And this is apparently some emergency that he had to check into Foursquare right here. And he's going, there's a color-coded, by the way. The green is over 70 miles an hour. So it's a kilometers per hour, kilometers, so not so bad. But you know, this guy is tweeting and Google Plusing. He said there was a fire. It was interesting. He took a picture. He had to post it. I'm like, okay. So these are the emergencies of his life. But people are obviously using their phones while driving. Now, we just have to convince regulatory authorities that this is actually common practice. I mean, I could hand over this research to them and say every single person was using their phone while driving, because they still won't allow certain functions in IVI systems, which we're trying to push. So it meets our agenda. But the fact is, people are trying to communicate socially while driving. You didn't know that, but it's interesting to see to what extent people are not really as aware of their behavior as you would think. Another thing that the technology helped us to do combined with the ethnography is when we would go, we would want to talk to people about, did anything unusual happen today? We asked this woman in Brazil, did anything unusual happen today? Because we had already seen this data. We hadn't showed it to her yet. And then we're like, well, can you tell us a little bit about this drive? Because, you know, we couldn't figure out really where you're going, because you kind of start here and you go here and then you go do this and then you go here and then you go, then this happens, and then we're just like, and you're calling people and you're messaging and what's going on? And she's like, well, I got a call from my friend. There was a group of pirates in the area. We're like, pirates? Okay, interesting. She's like, well, what are pirates? It turns out they're gangs of like 50 guys in Brazil who go as a gang and like smash cars one after the other and rob them. And the police can't stop them. The police, they don't have 50 guys. So, you know, there's nothing to do. So there was a band of pirates in the area. She'd heard gunfire. She went one direction. She heard another shot. She went somewhere else. She finally stopped at a McDonald's where she felt safe. The interesting thing is that she said nothing unusual happened this day. So, kind of like, I'm like, okay. As frightening as that is, it also shows that how you can use technology to inform a social science interview, because this is a talking piece. Really, I mean, you know, you can say, well, you don't have statistical significance, you only did a small sample in each location. Fine, but we got them to talk about things. Another guy was in China. I don't have that slide, but we're like, what is he on, Neighborhood Watch? It looks really weird. And he's like, no, he's a black taxi. He's an illegal taxi service in China. So like, you can ask people, what are you doing? And like, oh, and also I sell women's hosiery out of the back of my car. I'm like, okay, because we couldn't understand his driving patterns. But then when we used the driving patterns, this is doubly informative. It informs us of what people are using their cars for in terms of daily practice. How could you monetize that, or people actually, you know, want to do some sort of business out of their car? But then also, you know, it makes us aware that when it's just something as simple as GPS and cell phone app tracking, which many things do, can tell you a lot about what's going on in people's lives. Another thing, you know, we found was this woman was constantly playing a fishing game as she was driving around China. And, you know, and of course, you know, we just asked her about that. And she's like, oh, I gave the phone to my kid. Right, it's pretty easily explained. But a lot of people do that even though they're not supposed to. So we saw a lot of like kids gaming with their parents' phones. We have some virtual machine ideas about that. But anyway, so we sort of took our findings and also some of the technology we're working with, and we made this lovely vision video, which I'm going to show you, and then I'm going to sort of decompose it because it does actually represent real technology.
Over the last 100 years, the automobile has transformed our world. Cars have freed us, but they've also led to challenges in safety, congestion, pollution, and isolation. We have the opportunity to change our future through advanced sensing, interconnected data, and intelligence embedded in our cars and the environment. We can create a transportation system that knows who we are and where we need to go. One that's connected and cooperative, easing the burden of driving and making transportation safer and more efficient. 8:15 Tuesday morning. A parent, his child, and a classmate leave the house on their normal drive to school. They each have a unique data profile of their travel preferences, routine destinations, and upcoming trips. As they approach, the car securely links to this data. Inside, the car recognizes its occupants and the trip they're taking. Utilizing their data profiles, the car dynamically adapts to them, changing in-cabin settings, music and media, fuel efficiency, and driving performance. Anticipating their destination, school by 8:30, the car displays the different routes they normally take. It accesses real-time information about delays and helps them choose the safest and most efficient path. In the back seat, the children start a game. This game allows interaction with the outside environment as they pass by. Back at home, the child's mother checks her phone. Traffic is heavy on her normal commute to work, so the transportation system offers her an incentive if she takes a different route and leaves a few minutes later. When she enters her car, her mobile device seamlessly and securely connects with her vehicle, displaying her chosen route and relevant trip details. As she drives, her car senses and communicates with the environment around her. Connecting with an upcoming traffic signal, her car tells her that the light will shortly change to green, as no other vehicles are detected at the intersection. To enhance her driving, she's given an augmented view of the world around her. Dynamic driving zones, in this case a virtual bike lane and a school bus zone, make obstacles normally obscured suddenly visible, helping ease the flow of traffic. Knowledge of road conditions is shared in real time between vehicles, allowing drivers to avoid obstacles and hazards before they're encountered. In this case, an approaching car is alerted to the delay and an alternate route is suggested. This car merges onto the freeway, linking to the vehicles around it. They share their general destination and where they're exiting, forming an impromptu group that begins to drive together autonomously. As the car nears the driver's destination, it connects with local infrastructure to find available parking. Accessing data collected from sensors and other cars, a location is negotiated and reserved, taking into account cost, safety, and driver preferences.
Autonomous parking.
Over time, increased intelligence, sensing, and connectivity in our cars and the infrastructure around us will change our experience of travel. We'll work together, individuals, groups, cities, and governments, to travel more safely and efficiently. And our very idea of transportation will shift to one that is more sustainable, cooperative, and ultimately freeing.
Okay. Now, I wanted you to see that video, one, because, they gave us so much money to make it, but also because it actually represents about 15 separate engineering projects that were going on. And the vision video goes way too fast to explain them all. We actually have a technical white paper that I can't, unfortunately, release it because it has a lot of proprietary stuff in it. But the vision of the transportation portfolio was that the car is going to be driven more by data than by the drivetrain. So right now, all of our car manufacturing companies that we speak to, they really primarily see themselves and the car as this. Foundationally, it is an engine plus a drivetrain. This is what they do. They actually outsource the IVI and vehicle infotainment system and sensing systems as if it's a car stereo. So it's actually not part of their core business. They're about image, engine, and drivetrain. Unfortunately, the way we conceptualize the car is as a data vehicle, and all the computation of course we're a computer company, so we have a little bit of a different frame. But I actually firmly believe that the future of transportation systems will be more driven by data than by the drivetrain. So I want to talk. I want to talk about different scenes from the movie and talk about what they represent. A lot of this is about your data profile, and I've talked to some people about security and privacy. There's this idea about what you expose, that you have some sort of data exposed on you. Right now, the cell phone is the primary vehicle for that. So what do you expose on your cell phone? We let the father here expose his temperature preferences, his schedule, these were all like, okay, this is my, go back. So this is his usual route to work. This is where his appointments have to be, what his preferred temperature setting is, his to-do list, his music, that his phone can plug into the different things. The kids they have less data exposed. This was intentional, this idea that children would have a different profile or sort of a different amount of exposed data on them. Maybe they have an iPod or whatever device that they're going to have in the future. It exposed, yes, I have to go to school. Yes, I have to go to school. I like this music and I like this game. So these might be allowed exposures of the child's data. Remember, this is also the child that belongs to the family, and this is the child who is getting a ride from the friends. And also we found carpooling schedules were a big deal. So this idea about data scheduling, tracking, and data exposure, and then how the systems come together was a very important sort of process for us. So this scene combined. We have an in-vehicle infotainment system that can actually split 4 ways, and we can have 2 embedded screens in the back of the cars with cameras. This is showing that we can have multi-person face recognition. We have an algorithm that's actually robust to recognizing a small set of people and recognizing strangers as sort of what we call a garbage class. We recognize the people. Either the profiles are stored or they can be taken off the phone. They say that, okay, well, what's a compromised temperature? The father likes 73, and maybe the children prefer it slightly warmer, or this assumption made about children needing more warmth, and so they adjust it to somehow 74 as a compromise. Coming up with these compromises is a whole science unto itself. We do automated homes, and it usually has to do with a lot of social status, like, the grandmother just gets her way, or it's not usually an averaging function. So there's some logic behind that. This idea of having this pass-through video to the front driver so that you don't have to turn your head to see what's going on in the back seat was actually seen as a safety feature. It's not actually that hard to do, and it seems to be something that people like. And then, so with respect to the music, obviously this is one of those situations where the child's presence and preferences take precedence. So, if the father likes obscene rap and the children are present, they might also like obscene rap, but there's a rule that you can't have that, or something like that. And we actually had one woman come in, she's like, well, I usually like to listen to this, but my kids here are like, I'll only listen to the nice rap. I'm like, okay. And she had 8 children. It was very interesting that she told us. But anyway, so we ran a lot of studies, and we found out, so these things are not just averages. There's some rules behind how you combine data and how to combine data intelligently. One thing with respect to route planning, the freshest data makes a difference. People would actually tell me they would look outside their apartment and look at the traffic rather than trust any of the information sources. So knowing, if there's going to be a school bus blocking one of the routes, if there's going to be a city garbage truck, a lot of these things are becoming monitored. You want to know where these congestion points are. You want to know very specifically and very locally. So if there's 3 ways to go to school, you want to know where's the garbage truck, where's the school bus, where is their local, like right now I'm having one of my local roads redone. So find me the absolute freshest, best data route. This was a concern that most parents had, that their children were becoming isolated with too much screen time. They weren't interacting with the world around them. So how do you bring, the real world in? It's shown right now as embedded on the glass. That's really not going to happen because the glass is cheap. You can imagine sort of a projection screen projecting this from an interior camera onto, if the glass could be coated, and then just tracking the child's. We do a lot with gesture tracking. We do, there's another video for Moby that shows all the gesture. We can see where the child's pointing on the projected image and then bring that information into the car so that, they're not really, but the idea is to engage them. When did they touch the screen? What was on the outside? What story can you tell about what they might be interested in? So how do you connect the child with the real world? There's not a child demand. There's parents wanting the children to do this. So this is one of the ideas that came out of that. This is another thing, this incentivizing drivers. This is going to be more of a government takeover thing when you start getting yourself taxed at different times of the day, which is coming, unfortunately, just to let you know. So right now, a lot of government Brazil is putting an RFID reader in every car to track mileage because there's too much ethanol being used, and that's not appropriately taxed. So they want to make sure you're taxed on road use. And in Beijing, there's certain days where you can't drive, and this is more common. There's days when, according to your license plate, you can or can't drive. It's not too hard to imagine that there'll be a rolling tax on driving, that you'll be taxed for road use. You could be taxed for driving at the highest congestion hours. It's not too hard to imagine. It's technically extremely possible. And those RFID, if you have Easy Pass or whatever, you know, the readers for that aren't just at the toll booths. You know that? They're everywhere. So yeah, and they can track you. And besides, you know, if you go between point A and B, at, you know, I don't know, 70 miles per hour on average, they can track that too. They choose not to at the moment, but I'm just, you know, letting you know. Okay. So the idea is we had to put a positive spin on it for the vision video, but like, not you're going to be excessively taxed if you happen to leave now. It's we're going to incentivize you with some sort of positive incentive to drive later. But this is how we envision road use in the future will be more dynamic, and will be guided by computer algorithms optimizing things. This is another project. I actually was involved in this. This is smart traffic lights. How could a smart traffic light communicate with people? An abundance of issues, like whether or not someone's going to blow through on the side. This actually led to a project I was doing with Google Glass, and you actually had the countdown so that you could actually look away at the intersection. Did you hate it when, like, you know, there's that person who, you know, just doesn't seem to start their car on time because they've been texting because they were busy? So this idea is you'd have it on the Google Glass, so even if you would look down, you'd still see, you know, it'd be like 5, 4, 3, okay, put it down and get ready to go. So it would let you know what the countdown was, but it all sort of depended on the traffic light being able to communicate to you. And all we have to agree on is a universal radio standard that everyone wants to use for this, and it's going to be extremely possible to know when the traffic light, they're all on a schedule, actually. So one thing that we were actually saying is, look, many of them are just on a schedule. So if it can just announce to the cloud, you will know what time it's going to turn. So you should be able to, by GPS, know where you are and know what the schedule of this light is and just be able to look it up. So if it runs on a schedule, so you don't actually need the radio communication standard, it'd be nice. And in the videos, we imagine that your car could make a request. You know, if no one else is coming, I'd like to go through. And this is also to save gas, because braking your car is actually a tremendous waste of gas. So if you, I always hate it, like when I approach a red light, I always want to slow very far in advance on the hopes that it'll turn green and I don't have to stop, so I can just push through. And often if there's other cars that are stopped, I pass them because they're like, haha, you came to a full stop. But this is trying to help everyone do this. You know, let them know, well, don't bother full stopping because it's going to turn red in like green in 0.5 seconds, so you can go. How do you make efficiencies with data and communication? Augmenting perception. Bike lanes, often hard to see, often hard to know if there's a bicyclist in them. So one of the things, we didn't talk about it here, but one of the ideas is that you could also have a bicyclist with a sensor that would let people know in the general area that, and light it up to let them know a bicyclist is in fact in the lane. My husband actually drives a motorcycle. It's impossible to see motorcycles because if you're in the speeding lane and going 25 and the rest of traffic's going 15 and he's coming at 85, splitting lanes down the middle, even just checking over your shoulder, you can't see him. You cannot see him. You have to look in your rearview mirror to see a motorcyclist. He's been hit twice. I don't advise driving a motorcycle, by the way. I also can't seem to stop him. But you know, making other people and obstacles more visible on the road. There's a secondary part of this, and with sort of low-cost autonomous driving, being able to do lane tracking and changing. In fact, not this projection, but actually painting streets. It's so much easier for a car to track a color. So if we could just paint the streets different colors, it's very easy with a cheap camera to sort of find the lane. You can do it actually now. There's a whole MATLAB demo if you go to MATLAB, do lane tracking. The problem is sometimes the paint's bad. But I mean, you know, for the cost of paint, you could probably have low-cost autonomous driving to some extent. And that and 1D radar like Mobileye, you could just, you know, for range finding, just, you know, stay in your lane and don't hit the guy in front of you. As long as, you know, nothing else happens, you're all fine. This also lets you know that there's something like a school bus around the corner. This is information you'd have to get from the cloud. And one of those things is there a likelihood of a child deciding that it's a good time to run across an intersection? You don't see the school bus here. There's this idea that it's, you know, there's this hidden obstacle. So what do you know about these sort of hidden dangers? They talk about, you know, an efficiency of blockage, but I would also be concerned about a school bus emptying, a content of people. I've also seen people run for buses in ways that are extremely unsafe that I would like to be pre-warned about. This idea that and also signs that are time dependent. This is another thing, like school zone during these hours, during this time. Well, if it's a school zone now, light it up for me. If it's not the hours, and this also happens to do with parking spaces. Sometimes the rules for parking spaces are so twisted. You have to park first. You're like, can you find the sign? Where's the sign? Okay, second Thursday of the month. Okay, is it the second? Just let me know if the parking space is available or not available and for how long. How do you make this information visually present? I talked to someone about who's a professor of visualization earlier today. How do you visualize all that information that's on the parking signs and the warnings? How do you make that present to drivers so that they can make decisions in the split seconds that they have to make the decisions? All right, and this is the most future-thinking thing, M2M autonomous driving. Autonomous driving right now sort of requires very expensive sensors. I'll be talking more about this later. One of the easiest things to do is what we call caravanning. Caravanning means you just follow the car in front of you at a safe distance. You all get in a row, and you're just following. All you need is 1D range finding. You can get that pretty cheap. Now, how do you find these friends of yours who all want to go to the same place? Well, you make an announcement. You just sort of publish your location like Waze does now, but it needs to be slightly more accurate. We say, well, what exit are you getting off at? So if you all are getting off at around the same exit, and there's some limit of you, 3 or 4, like this is for 3 or 4, the HOV lane becomes for 3 or 4 car caravans. You find each other, you get in a line, and the first person drives, and they get some sort of karmic credit, and the rest of you just sort of act like you're on a virtual tow hook with this person, and you can get, low-cost autonomous driving for your ride. And then you have to do some sort of karmic payback later or some sort of fee. But you should be able to, because of, it's easy to find a lane, especially if it's painted, to stay in your lane and just follow. This is called caravanning. It's the simplest form of autonomous driving. It's not expensive to do. Not even that hard, especially on a highway. You don't have any cross traffic. So pedestrians, no bicyclists, no random things happening. Just stay in your lane, follow the guy in front of you. Done. At least in theory. Hold that spot. Now this, I heard some people laughing. This actually exists now. So at Portland Airport, you can actually reserve your spot. You start paying for it at a certain amount of time. There's a little barricade that comes up. It's electronic, goes up, goes down. You reserve it. It's waiting for you. You should be able to do that, right? Just reserve spots. I want to rent that spot. I rented it, and it's mine. I don't have to worry about finding parking because I reserved a spot. It's not that hard to do, actually. You can even do it by calling, and people can actually manually put a cone if you don't believe in technology. But this idea about reserving parking spaces, we think it's kind of phenomenally revolutionary. And everyone's like, yeah, I don't know. I'm like, what are you talking about? It's great. It's a great idea. But they do it at Portland Airport. You can do it. It's not that hard. We thought it was a great idea. Autonomous parking. Aside from caravanning, I think the first form of autonomous driving that we're going to see is this autonomous parking. What does that revolutionize? One, it can revolutionize parking, because now instead of leaving enough space for the doors to open, you can park the cars right next to each other. You don't have to leave that space because no one's in them. It just sort of drives in, and then you can park them much more efficiently, at least in this direction. And then, you can get dropped off, and it can go park in a far space. I mean, let's say we gave them all to the people who currently qualify for handicap spot right now. One, you don't need the wide handicap spot because they get out here and then it can go park itself. Second, they don't need to be near the entrance anymore. They can go take their time and park wherever they need to and then come get you when you want to, like Kit Car used to for David. So I think that we're just going to see autonomous. We're going to see caravanning. We're going to see autonomous parking, especially because autonomous parking can go at very low velocities, and it can go send your car to anywhere in the lot. And I have 3 kids, and my greatest fear is that the 3-year-old is going to go dash while I'm trying to get the other 2 to shut their games down and get out of the car. Right? So I'm like, get out of the car now, shut the game down now. And this 3-year-old's like, gotta go, bam! And I'm like, he's almost been run down twice. And I'm like, no, and they're squirmy. You can try holding them, but they run. So it would mean a lot to me to be dropped off where I can get the 3-year-old out and onto a sidewalk and get those other 2 out, and then just send the thing to go park itself and come pick me up. Because one thing you don't want to do, for those of you who have children, try to cross a large parking lot with 3 children. So I think we will see there's a lot of high value around autonomous parking. And it's low risk because the velocities involved are theoretically non-lethal. And a lot of it's on private property because you're in a parking lot area anyway. Metrics and opportunities, this is talking about how some drivers are interested in their behavior. And also, like, how did I do with respect to congestion? How did I do with respect to eco-driving? How did I do with respect to gas mileage? This is sort of this idea of gamifying your drive, to sort of give yourself points for I was eco-friendly today. I didn't impact air quality because I reserved parking. I didn't drive excessively. What is my carbon footprint thing for the week? What is my how am I going with respect to my goals? There's also the idea of renting your car. Like right now, Zipcar, why do they trust anybody? Right? Because there's sort of a code, there's a sign up, there's some sort of validation. Could people apply that to their own cars? Like this could be the Airbnb of cars. You want to park your car, somebody wants to rent it for a few hours, it's known how long the renting is. There could be we have this thing called the immobilizer key. It's an NFC pairing thing that can start your engine. It can then you could have some limited control over the car. What's the radius you're allowed to drive it, and for how long? And then it gets monetized. You also have the NFC pairing to the phone. The phone could go something like Google Pay, Apple Pay. You can get the monetization per mile. It gets sent to your account. You also have a live tracking of where the car is if the location service is on. So it's like, what are the things that are going to enable people to rent out their cars, especially at an airport? I drive to the airport, I want to pay airport parking for 5 days. Instead, I hand my car off to somebody, they use it for 4 days, they pay me, they leave it there, I pay for 1 day parking, pick up my car, go home. So we're looking for opportunities around efficiencies. A lot of it has to do with trust, a lot of it has to do with attestation and tracking, because you don't want to give your car to just anybody, and there has to be insurance and this, that, and the other thing. But we have Zipcar. Somehow these things seem to work on a large scale. We suspect that there's something here. Okay, so that's a lot of the vision. These are a lot of the projects that we're working on internally. I decided to call out one particular project that I'm working on with a professor in National Taiwan University, M2M sensor fusion. Like, how do you enable autonomous driving on a budget? And we decided, because it's great. Google Car's great. It's fantastic. It's lovely. I just love it to death. It's fabulous. It also costs about $150,000. So it's only going to benefit people who can afford it, or you're going to see Google Taxi, and then it's probably going to cost more than a regular cab, and then the benefit starts to look a little shady. What I really want to do is enable everyone to have autonomous driving, because it works just a lot better that way. Intel's fabulously interested in autonomous driving. Why? Because there was a rack of Pentium in the back of Stanley, the first one that won the DARPA challenge. It's just there's a huge amount of compute. Right now, Intel has the lion's share of the autonomous, in fact, all of the autonomous car market. There's nothing more that we like than to see as many of our computers as there are in these autonomous vehicles. So we're 100% behind this. And just so you know, in case you don't know, there's the one LIDAR, light detection and ranging. It's the stuff that people used to use to do sort of field surveys. This is what the car uses. It has this little spinning 3D laser rangefinder, and it just does sort of just giant depth perception in all directions. The only thing is, this piece of paper looks as solid to it as a concrete brick. A snowflake also causes it problems. Anything you hit a leaf looks as solid as anything else. So that's why these cars are currently driving in California and Arizona and not Dartmouth. The leaves and the snow, because that makes the landscape change. Actually, I forget exactly, yeah, so the algorithm that's used is for the roboticists in the room. Robot people? No? Okay, simultaneous localization mapping and moving object tracking. It's robot navigation. The first part is to figure out where you are and then what else is moving. The Google car and other things actually cheat. They've pre-mapped everything, so it's actually map registration for the localization. You just find where you are in the map. And then you actually do the moving object tracking around that so you don't hit anything. Main drawback is high cost. 3D laser scanner, that LIDAR thing that's absolutely fabulous. Doesn't work as well in snow, but over $80,000. So what we were looking at is looking at 2D laser scanners and stereo cameras to try to replace the functionality of the 3D LIDAR. The idea is that each car would be able to sense each other. You can do depth finding in 2 dimensions, so you get an idea of what the distances are. You'd actually, with the stereo camera, be able to have a visual tracking of each object. And then by broadcasting your position and velocity and route plan, we actually have a very complicated model. You're announcing your future plans. People are like, well, what about the latencies? You can't do it fast enough. It can do it fast enough because I can predict the future. You tell me you're going to brake. I'm braking in 5, 4, 3. Okay, I'm expecting it. I'm expecting it. You're braking. I'm braking. I'm getting ready. Everyone knows, right? So one of the things that we're talking about is not just, GPS. Right now, all that the model has is the GPS. But if the cars start talking to each other about future plans, like, hey, I'm going to leave the caravan in like 10 seconds, in 9 seconds, you can share the information. You can make a plan. That's how you overcome latency. You predict. As long as something completely unexpected doesn't happen, you're fine. And when it does, then that's when you have the issues. But then theoretically, the cars can react faster than the humans. If you have the radios going faster, and if you do, there's a separate protocol for V2V that's direct line of sight that can react faster than a human seeing the situation, thinking about it, thinking about moving your arm or leg, and then, it actually, once cars can do it and do it well, we can minimize what we call safe stopping distance. Safe stopping distance is entirely gated by the human's ability to react. So once cars can react faster, reliably, then you can pack more people onto the freeways and go super fast. Because remember, speed is also a factor in the safe stopping distance, because that's like from the time you hit the brakes to the car stops is the stopping distance. So if you improve any of those things, you can hyperpack the freeways. Okay, just letting you know. This is the community. I am here. 2 cars are in front of me, and then they talk back to each other. And you can pass the information back. That's the idea. It's like, oh, crash up ahead, pass it back. We had a laser scanner and a stereo camera to replace the LIDAR, and we used them for both localization and nearby object detection. Let's see if this works. This is a simulation. We started with a simulation. And so what this shows is this is like when people collectively participate, there's a cooperative and independent localization, and as the cars get closer to each other, and this shows the scope of where they think that they can detect the other cars and get the radio information. So they did this simulation that shows that the more cars that are participating and sharing information, the better the localization is for all the cars. And this was the first modeling attempt that we did. We started with a computer simulation to sort of prove it out in theory. It's always a good start. It's low cost. And next, we actually built robots. So we couldn't afford cars, so we actually built these 2D robots with a DSRC radio, GPS, stereo camera, and 2D laser scanner. And then we had the robots go around and try to track each other. It was quite nice. And so here you can see the robots in action. Oops, did not go. Okay, robots. And hopefully you'll see some robot action. No. All right. Let's see if we get these robots going. All right. Yes, okay. All right, so I'll show you this one. So these are 2 students. The students are pushing the robots around. You can see the front visual for each of the robots as they're going. This is using the SIFT algorithm to track key points and identify people as the robots are going in real time. It's mapping, these are the edges. This is for the 2D LIDAR. The blue dots are from the LIDAR, and then the red dots are from the camera. And this is the map that the robot sees as it's going around. And this is what it's basing it off of. It's definitely not, I remember I showed you the LIDAR map. The LIDAR is much more detailed. But the idea here is that is this good enough? We're looking for the good enough sensing and tracking that could possibly enable autonomous driving at low cost. And so this is just showing the difference between using the GPS estimates alone, and then using, this is just with shared GPS, what the estimates of the tracking of those two robots that were pushed back and forth between each other. And by sharing the information back, by co-sharing their location, they got a far more accurate tracking of where they were. And this is just our first step into trying to improve accuracy with low-cost sensors by sensor fusion to try to get a better estimate using GPS, and then on top of it layering the stereo camera and 2D LiDAR. Beyond that, we have a secondary effort, which is when you talk about who should be in control, the driver or the car. Now, the car is imperfect, but drivers are also imperfect. So we actually wanted to have an estimate of whether the driver was concentrating or distracted. And here you see that this is measuring whether or not the driver's looking forward. It does an estimate of hand pose, and it also says how the driver's distracted. Are they on their phone? Are they drinking a cup of coffee? Are they visually distracted? Are they audio distracted? And how to interrupt them to get them back in control of the vehicle. And this is just showing, this is a point gray system that does hand pose detection. This is showing that the one hand is on the wheel, the other hand is holding a cup. This is what the computer sees, and we have a computer vision algorithm that works on sorting out what kind of distractions the driver is under. So this is all has to do about the handoff, this question of the autonomous driving handoff when something happens. When can you reliably hand something back to the driver? If there's two cars about to crash, if they're communicating with each other, do you want to see what state each driver is in to see who can, what are your resources? Basically looking at your collective resources as to how do we avoid this crash. Okay, and then this is this idea that when cars talk to each other, we had this idea about M2M gossip that talks about, look, like if I'm trying to follow a friend of mine to a destination, maybe visually that'll show up as like follow me, and it'll highlight where they've gone, especially if like a car gets in front of us. I'll still see a pop-up of where they're going to sort of visually track them in the IVI system. Another thing is if the car is watching you, it can also make an estimate as to whether or not you are distracted or maybe dangerously impaired. And how would it be able to potentially announce that to other drivers? They might just say, you might know that there's a drunk driver, but it might just show up as a distracted driver in the communication between cars' systems. And this is just highlighting what the future road might look for. Is like one's your friend that says, follow me, so you're trying to track them. The other one is this is a distracted driver, so you need to avoid them. Yeah, and so basically that's kind of the end. I wasn't sure how much time to leave for questions. All right. Good. Okay.
Thank you. We have time for a few questions, and then we have a reception immediately afterwards to which everyone is invited, and will give us the opportunity for one-on-one conversation with Dr. Healey. So are there any quick questions?
Yes.
Okay. So, sort of the world that you paint. Excellent. So the world that you paint is really cool with a lot of like interconnected parts and everything. Mm-hmm. So I guess my question is sort of about the rollout of that.
Yes.
How do you incentivize all the different entities, like the infrastructure, many different car development companies, et cetera? How do you get all that? How do you see all of that coming together without a significant sort of top-down approach?
It's an extremely complicated process. One thing that is, with any M2M system, they're talking about a radio standard. Getting everyone on the same frequency, literally, is part of the challenge. And whether or not we're going to go, currently there's a DSRC standard out there that's backed by GM. They promise it like within the next 3 years that this is going to be the standard for driving. There's also an IEEE standard called 802.11p that has, like, unfortunately, a lot of security holes in it that runs on top of that radio standard. So getting people to agree on a standard and a protocol is incredibly difficult. We have a number of, like the IEEE community standards. There's different radio standards. Right now people are like, well, maybe we should wait for 5G. Getting people to agree on a radio standard is incredibly difficult and political. There's no way around it. But eventually people will find ways that work. And maybe it's going to be the internet, or maybe it's going to be, and there'll be workarounds. And as soon as people see the workarounds happening, I think they're going to go for a standard. I think it's going to fuel that. Governments make their own decisions. There's more than one government in the world, it turns out. China can make arbitrary decisions much more, can make top-down decisions much more easily than the United States. There's a lot more there's different players in each country. Like Brazil has decided that they're sick of getting that people will use ethanol and not pay a road tax. They've decided to, mandate RFID tags in all vehicles. I think once people see that happening, I think that might spread to other countries. So in terms of how do I see the rollout, okay, PDX, you can reserve parking. I think that people would be willing to pay up to double to be able to reserve parking. That's not hard to roll out, that you're reserving a parking space, so I think that's going to happen. Caravaning, already I've seen ads from Hyundai that show caravaning. I've seen ads from Audi that show autonomous parking. So these things are already happening. They're happening autonomously. They're happening without the M2M system. So I think M2M is going to be an augmentation layer on top of everything else. And I think it's going to start working on, you could say, okay, well, I'm just going to do it privately on low-power Bluetooth. Right, that's good enough. I'm just going to jump the gun and say, well, within my parking structure, it's going to work with anyone who has this. Qualcomm's actually offering DSRC for free on their phones, so I think that's interesting. So how is it going to roll out? I'm not sure. I see bits and pieces of it coming. Like sort of my job is to say, well, look, this is what I see as the vision. This is what I see as the pieces. And how exactly it's going to roll out, I'm not sure. But this is, be prepared for this. There's not a one plan that I have that I'm keeping from you.
Another question?
Yeah.
Yes.
I think just like the parking space. Okay, thanks. Just for the parking space, we need to schedule a parking space for individuals. It just means it's kind of like smart parking. I suppose it should be find the global optimal solution for the smart parking. So what's the global optimal? It's just like to schedule the parking space in the Dartmouth campus. So the global should be the Dartmouth campus or the New Hampshire or the US. I'm not sure about that.
It's
and
extremely
Yeah, and my second question is that if we just want to give the global optimization for the smart parking. And for individuals, they could not get their own best solution. They must accept the suboptimal solution for themselves. So whether we need to accept this suboptimal solution for themselves, we could find a better one, I suppose.
I'm just going to blow your question away and say that there is no global optimal solution. It's going to be country dependent for sure. And then a lot of it's going to have to do with privilege and capitalism and like how much are you willing to pay versus how much do you feel entitled. Like, Dartmouth might say this is reserved for faculty, period. Right now there's a little sign that says that, but pretty soon there'll be a little barricade.
There is no sign that says that.
Well, obviously something that should be negotiated. But also parking structures are differently owned. Whenever you want to talk about a unified parking solution, you're talking about negotiating between public parking, private parking, restaurant parking, things that are parking lots, things that are only good for when you're in the store. A lot of store owners want to make sure that you're only parked there while you're in their store, and they're willing to, you get to check in and they Wi-Fi track you and you better go back to your car after you leave their store. So there's different things that people are interested in terms of parking optimization. Are you optimizing for the parker or the person who owns the parking garage for their store? Those are two different optimality criteria. So when you say global optimum, I also believe that a global optimum is no parking. That ideally, you would have these seamless, you would have a detachable pod car for your storage that everyone would have like a little shopping cart that pops off the back of their shared car, and that these little autonomous pods are just going to take us everywhere, and you summon one like Uber, but it shows up like that. Stick your little, car seat and everything else onto it, and then you go off. And nothing has to park because everything's being utilized. So to me, that's the optimal parking solution, is no parking. But until then, you're going to see a heterogeneous collection of profiteering and optimization that is going to go on up till then. But I do think it's going to be data-driven.
I think I'm going to quote you on that, by the way, as we think about the expansion of the engineering school.
Yes.
The optimal parking solution is no parking. We have time for one final question before we break for the reception. Is there anyone else with a quick question? Yes, Geneva.
Hi, so I did some research in the ASL lab at HA Zurich, and we worked on a similar problem about 8 years ago, looking at ubiquitous robots in urban settings where they were trying to figure out how to protect the geriatric population from crashing into each other. How do you see the collaborations that you guys have with universities helping to push your mission forward, or what collaborations might you have, or are you looking to do with universities like that have big robotics labs?
Yeah, so we actually rely very heavily on universities to do a lot of our forward-thinking research. This research was entirely done in National Taiwan University. So I'm the PI for the project, but all the research is done in Taiwan under Professor Bob Wang. We also collaborate with CMU, who has another, we worked with them at the DARPA Urban Challenge, their entry for that, and we work with them now on their autonomous driving lab. I have personal collaborators at the Age Lab at MIT, and they're looking at different, sort of elder needs. But what elders need is freedom of mobility, regardless of their ability to drive. And that's where I think fully autonomous driving is. And they don't want to wait for the T to come pick them up in an hour and a half, that's for sure. They want to be able to go where they want to go, when they want to go, and they don't want any questions, and they don't want to have to justify it either. So they want to be able to summon transportation and have it take them. So just like, but basically it's the role of a taxi. But you need an autonomous driving that's cheaper than a taxi, or free, ideally, if that's part of your new Social Security benefit. Once you turn 65, for the benefit of everybody, we just give you free transportation.
On that
Just saying.
Join me in thanking